Okay, let's go ahead and begin. My name is Rick Wise. I'm working with the North Texas Semiconductor Institute at UT Dallas, and we have a great opportunity that we want to share with you today. Thank you for joining. I'm sure there'll be a few others join as we get underway. But before I begin, I would like to turn it over to Dr. Ted Moise. He's the director of the North Texas Semiconductor Institute, to say a few words of welcome. Ted?
Hi, welcome very much to this seminar, and thank you for your interest in this North Texas Semiconductor Institute Master Scholarship Program. As you may be aware, this is a great program in which you're going to be offered, if accepted into this program, a free tuition and a stipend in order to get a master's in science in a technology field related to semiconductors. And the whole motivation for this is that Texas is the home of many large semiconductor companies, and they love to hire MS students who are experienced in this technology, and they will be hiring students moving ahead in the future. And so we're trying to build up the number of students in this field going into a semiconductor industry with a master's. So we look forward to any questions that you have today. As you may know, UT Dallas was actually started by Texas Instruments in the 1960s and has grown dramatically since its start. Now has almost 30,000 students, 20,000 undergrad, 10,000 grad, and a large number of engineering students. So hope you enjoy the webinar, and please let us know if you have any questions. And good luck to you in your pursuit of a graduate education. Thank you.
Okay, thank you, Ted. Before I begin, just the legal disclosure: this webinar is being recorded. By attending this virtual event, you consent to being recorded and grant the University of Texas at Dallas and the North Texas Semiconductor Institute the right to use your image, likeness, voice, and/or any information you provide during the session, such as Q&A or chat comments, for marketing and promotional purposes. This includes, but is not limited to, use in university publications, on the university website, and on social media channels such as YouTube, Facebook, Instagram, LinkedIn, and others. Okay, thank you. And now we'll begin. So, as Ted said, this is about a fellowship that is available here, particularly that will help prepare you for a career in semiconductor technology. This is the things we'll cover today. Talk a little bit about the industry itself, the need of the industry, this MS fellowship opportunity, and then go through the fellowship requirements, the benefits of the fellowship, and then how you would apply. And then we have 3 of the 21 participating faculty advisors for this program that are going to talk to you a little bit about their research, and so give you a flavor of kind of the types of research that are going on and that you would be perhaps participating in as you choose an advisor and a research topic. And then we'll close with any questions that you might have. This is the QR code. I'll just stop here for a minute if you want to capture that with your phone. This is the QR code for the scholarship website. It will have a lot more information. I'll go to it briefly at the end of this presentation, but anyway, that's where you can get more information and also step you through the application process. So if you're not familiar with the semiconductor industry, I want to start with this slide just to give you a little bit of the history of the industry. And this goes back to 1985, when the worldwide semiconductor revenues were about $30 billion. And what you see on here is some of the key technologies and products that have really driven the growth of the semiconductor industry to where it is today. But throughout the 80s, personal computers drove a lot of the growth. And then as moved into the 90s, mobile phones that were first introduced. And besides the old car phone, which you had, which was a clunker and you had to pay a lot of money for, but the mobile phone that you could carry in your hands, those really came out in the 90s, and you can see drove a lot of growth in the industry, topping 100 billion in 1993. and then 150 billion by 1995. Throughout the latter part of the 90s, the revenue was relatively flat, but of course stayed high. And then the late 90s, you may have heard of the internet bubble. The internet became widely used, widely available. A lot of businesses were started for online shopping, online use of the internet for selling products. Uh, and the other thing that happened around this time was Y2K. As you may know, there were a lot of concerns because a lot of the computers in use at that time uh, had not had to deal with a change of a date that involved more than 2 digits for the year. And so that there were a lot of changes in, going from the older hardware to the newer hardware. And so that drove a lot of growth. You can see it pulled back a little bit after that in the early 2000s. And then the big thing that happened in the mid 2000s was the introduction of smartphones. So now you had the internet, the computing power, all in the palm of your hands. And of course, that really drove the industry on up. Of course, there are other things as well, but smartphones, I think everyone would agree, was one of the main drivers, and the industry reached $300 billion in annual revenues by the end of by 2010. And throughout the next decade, of course, it became not only smartphones, but smart everything. That was sensors on everything, smart automobiles, smart appliances, smart security systems. So those things have really driven the industry, the growth throughout the rest of the 2010s, and reaching 500 billion in annual revenues in 2021. And since that time, of course, these other things don't go away, but you keep adding to them. And for the last few years, I think AI has been one of the big drivers for the industry, not only in terms of the AI chips, but for all the things that it drives. AI centers require a lot of energy, and of course, you have power management type chips that have to go into that. So AI, I think everyone agrees, is the next big driver. You can see the big upturn here for 2024 and expected forward. It's yet to be seen if this is a bubble or not, but I think all indications are it's going to be, a driver that's much bigger probably than all the previous ones. The other things I want to call your attention to on this slide is that a lot of semiconductor manufacturing was being offshored going back to the early 90s through the mid 2010s, and a lot of that was driven by lower labor cost. If you went into a semiconductor manufacturing facility throughout the 90s and early 2000s, and you looked in through the windows, you would see a lot of equipment. To build a semiconductor device may take, a few hundred up to 500 or 600 processing steps. And you had to have people to move the wafers between one piece of semiconductor processing equipment and the other. So it was fairly labor intensive. And so, of course, a lot of the manufacturing moved offshore, particularly to the Far East, where you could get a lot much cheaper labor. And then a few things happened that changed that story, and since then we've started to see reshoring of manufacturing. Factory automation came about really in the late 2000s and throughout the decade of 2010 through 2020, where factories were fully automated. Now you can go into a semiconductor manufacturing facility and look in the windows, and you haven't taken away any of the processing steps. You still see all the equipment there, but all the wafer handling is being done through automated processing that moves the wafers from one piece of equipment to the next, loads the wafers, unloads the wafers. So that labor part of the equation is kind of going away, and that's one of the things that's made reshoring possible. The other things that were probably bigger, we recently went through COVID a few years ago, and that really highlighted a lot of supply chain concerns that you could have a factory in Michigan waiting to build an automobile, which now had a lot of these semiconductors in it, but they couldn't complete the manufacture, the build of the automobile because they didn't have, you know, a lot of the parts, particularly the chips. So, and that happened in many other industries as well. So supply chain concerns became another big reason for, you know, reshoring manufacturing. And then the last one, I think, is national security. Obviously, you know, with AI and with all the other advanced chips, you don't necessarily want all of your chip making capacity being, you know, held in the hands of a country that may be adversarial. And so national security concerns have also brought a lot of the reshoring of manufacturing. And this is happening across the U.S., including here in North Texas, where some large factories are being built, including one by Texas Instruments and a couple others as part of this. So this is what's shaping the industry, and of course, to bring all this manufacturing capacity back on shore, you need engineers trained in semiconductor technology, and that's the purpose of this program. So, as I've said, there is a national effort underway to reshore the semiconductor industry, and in fact, the manufacturing capacity in the U.S. is expected to triple between 2022 and 2032, and you know we're 3 years into that, and we're already seeing a lot of the major expansion that's underway. You may not know, but Texas is at the epicenter of a lot of this growth. It's already home to 17.5% of the nation's semiconductor workforce, so that's right here in this area, and the growth is continuing. North Texas is the home to leading semiconductor companies, Texas Instruments being one of those. Global Wafers, which supplies the semiconductor wafers onto which the semiconductor devices are built, has built a big new facility about 40 miles north of here. Honeywell has a presence here in Dallas, Leonardo DRS, Coherent, which is primarily a 2.6 semiconductor company. They have a presence in North Texas and they're expanding, and Corvo. It's projected that in Texas alone, we'll need about 1,000 new master's level trained professionals in the semiconductor field each year. That's due both to this reshoring and growth of the manufacturing capacity here in the U.S., as well as the retirement of a lot of the workforce that was here from that earlier part of the graph that I was showing you from the 80s and 90s. Many of the people that started then, when a lot of the capacity and manufacturing was done in the U.S., they are now retiring and will need to be replaced. So here's what we're offering. That's the North Texas Semiconductor Program's fellowship. It will support master's candidates in material science and engineering, electrical engineering, or mechanical engineering. Right now, this program is funded for 2 cohorts of students. The first students would start in fall of 2026, and the second would start in fall of 2027. So right now, we're anticipating to start 10 students in each cohort for a total of 20 students. As part of the fellowship, that's, as Ted mentioned, it's a full tuition paid for 4 semesters, and then a stipend at least $2,150 a month for 5 semesters, which includes a summer of research. So the requirements for this fellowship: you must be a U.S. citizen or a U.S. permanent resident. You must hold a Bachelor of Arts or Science degree in physical sciences, such as chemistry or physics, or in an engineering discipline, prior to starting the program. Applicants with other bachelor's degrees would be considered on a case-by-case basis. You must apply and be accepted into the UT Dallas Material Science Engineering, Electrical Engineering, or Mechanical Engineering MS degree program. So you don't have to wait until you're accepted to apply for this fellowship, but you have to at least have made application to one of these 3 MS programs at UT Dallas. If you're a UT Dallas student and you're on the fast track or auto admit, you're also eligible to apply for this fellowship. You must have a 3.0 on a 4.0 scale GPA for your junior and senior level work, and in any graduate work that you've already completed. Of course, again, to get the fellowship, you need to go through the application process. So you would apply to one of the three master's programs, and then also after you've applied to one of those programs, submit your application to the North Texas Semiconductor Institute Scholar Program. As part of this Scholar Program, or as part of your master's degree, you will also complete the Graduate Certificate in Semiconductor Technology. So that's part of your curriculum. It's not going to be extra hours that are added to your MS, but that will be included in your curriculum, which is a benefit because it will indicate that you've had specific graduate level training in semiconductor technology. And I'll show you just briefly what that includes. And if you're in the fellowship, if you're awarded the fellowship, you have to remain enrolled as a full-time student. And this is a thesis-based master's degree. So you will need to do research and write a thesis as part of your master's degree. And that thesis would be on some semiconductor technology related project. So this is a little bit about the Graduate Certificate in Semiconductor Technology. I realize it's small print. I'm not going to read all of this, but basically it's 12 semester credit hours, which would be 4 classes. So as part of this, you would take one of these 2 courses, and then you would, you would take one of these 2 courses. You would select one of these 2 courses, and then you would take 2 additional courses from the list here. So in total, it would be 4 courses. And if you read through those, you can see those are all very semiconductor materials, semiconductor technology, semiconductor device related. So you will be ensured of having a good understanding of semiconductors after you graduate with a master's through this fellowship program. There's also professional development benefits. As a participant in this fellowship program, you will attend the MS Semiconductor Scholars Conference that's held at the Texas Institute of Electronics in Austin. You will come together with other students from other universities in Texas who are doing similar type work, and you will present your research and network with other students. We will also host a seminar series. So as a student, you will be meeting engineers from industry who will come in and talk to you about their work, so you kind of understand what they are working on, what kind of challenges you may face, what the drivers are in the industry, and things like that. So again, allows you to start doing professional networking with engineers from industry while you're getting this master's degree. We will work to try to coordinate so that you have individual industry mentors who you can talk to about their career, things that they've learned along the way, things that they might think you might be particularly interested in, knowing about or paying attention to as part of your master's program, and just good for giving you advice on the semiconductor industry. And then we will arrange visits to industry sites here in North Texas. And as I said earlier, there are several companies here. Many of those are expanding, and so there will be opportunities to go and tour their facilities. So here are the key steps. Again, the first cohort will start in 2026 in the fall. So the first thing you need to do is to apply to the UT Dallas MS program, again, in material science and engineering, electrical engineering, or mechanical engineering, and have your application into them, all of the requirements met for the application by January 15th. You, of course, can go to the UT Dallas engineering webpage and find that. Here's a link for where you would go to apply. Also, if you go to our Scholar program will have the links in there as well. After you've made application to one of these 3 programs, then get your application in also for the Scholar Program Fellowship and try to have that, or you will need to have that submitted by January 15th. So beyond applying for the master's degree, you would apply for this fellowship separately. You would include a short essay expressing the area of semiconductor technology that you would be interested in working in, and also what your future career goals are. And then you would identify 3 to 5 master's thesis advisors from a faculty list. Right now we have there's 20 listed there, and we had 1 new one that's going to participate. So there's 21 different advisors to indicate that you may have an interest in working with. And again, their profile will be there, tell you about their background and what kind of research they're doing. And then if you're selected for the fellowship, you will be notified by March of next spring, March of 2026. The program would start in fall of 2026, and then you would complete the program in spring of 2028. So we'll come back at the end and take questions if you have any questions about this. But now we want to let you hear from some of the participating faculty advisors, and we will start out with Dr. Kevin Brenner from the Materials Science and Engineering, and I will turn the presentation over to him.
Sounds good. Thank you, Rick. Okay, is that visible for everybody?
Yes.
Okay, fantastic. So yeah, I'm one of the few handful of advisors that we have at UTD, and what I'm going to do is just take a few slides to kind of talk about, what our research is. So what's the motivation for it? What type of projects do we have in our group? What type of lab environments would you be in? And then finally, just give you kind of a quick introduction to some of the projects that we sort of proposed for this this fellowship, and also the members of our group and the people that you'll get to work with on a daily basis. So I'll keep this short, and if you guys have more questions, my email is at the end, and we also have a webpage that talks more about our publications and what we do. But as part of the motivation for our group, I'm joined in the material science and electrical and computer engineering departments here at UTD. So our research is sort of an overlap of that. In general, the motivation is that today the way that we use and remove energy from semiconductor technologies is one of the greatest challenges that we face. And I always like to summarize this with 2 very relevant slides. The first is the slide on the left. This is something from Smart USA, which is one of the big research consortiums here in the United States. And basically what it shows is that the energy demand from computation, the green line, is quickly approaching, and in a few decades may exceed the energy production in the United States and the rest of the world. So the story is that with all these applications and artificial intelligence and computation and search engines, the energy that we're using in these semiconductor devices is getting very, very large. And so there's a need to build semiconductor technologies that are more energy efficient, that use the energy put into them in more efficient ways, and they waste less energy. On the flip side of that, forgetting about the energy efficiency, but just trying to deal with the energy waste, today, the energy density, so the energy per area that's produced by some of these semiconductor chips, is getting to be extremely large, actually comparable to energy densities in nuclear reactors. So we have really, really tremendously high hotspots and energy densities in these chips. And we got to pull that energy away so that the chip doesn't get too hot, it doesn't crack from thermal expansion, it doesn't melt, it doesn't get damaged. And so my research group looks at the way that electrical and thermal energy move through materials and convert between each other. And this is fundamental research that we apply to applications in energy efficient computing to support new applications like artificial intelligence. So we're focused on nanoscale devices, and we're focused on how is that energy that's not used by the semiconductor chip dissipated, and what type of temperature rises and thermal problems does that cause. So that's the motivation, and we like to think that we're focused on a problem that's going to stick around for many, many decades. But what type of work do we actually, do in our group? Well, most of the work that's done in our group is divided into two areas, both of which are relevant to semiconductor technologies today. One is nanoscale devices. So we build and test a variety of types of semiconductor devices like transistors. We look at a variety of interesting materials, everything from basic silicon technologies to two-dimensional semiconductors that are just layers of atoms to thin films that can be grown and manufactured at low temperatures. So we investigate new materials, we fabricate those new materials into transistors, and we electrically test those transistors. And so in a day in the life doing this type of work, this involves work in clean rooms. So many of my PhD students are, working inside these clean room facilities, doing lithography and patterning and etching and characterization using cool tools like scanning electron microscopes that let you see into the nanoscale, which is kind of the inset that I put there. And so that's one of the thrusts in our group. Another thrust in our group is just nanoscale and interfacial thermometry. So measuring thermal properties of materials. The thermal properties of materials are linked to the electrical. In fact, a lot of our semiconductor technologies today have their performance limited by the fact that they just get too hot. And so we do a lot of work looking at new materials that may work well for transistors, but we also try to study, how do they heat up? And when you drive a current through them or when you switch the transistor, how do they produce heat and where does that heat go? And so a lot of this research is done as our private lab, which is right down the hall from me here, where we use some really cool instruments like Raman spectroscopy that has special stages that can go to, 77 Kelvin or 1 Kelvin or go up to extreme temperatures like 1500 degrees Celsius. And so we do a lot of thermometry work as well, looking at new and interesting materials that may solve some of these thermal problems in the semiconductor industry. Now, we have a variety of kind of cutting edge research projects available in our lab. And if you go to the NTxSI sort of scholars webpage, we sort of provide some more details on these. But some of just the examples of the projects that you get exposed to would be things like stacking and working with two-dimensional materials, which are layers of atoms that may form better transistors than the silicon that we use today. We have work on fabricating nanotransistors or nanoscale transistors, doing lithography and etching and electrical testing. We have work just characterizing thin films that go into the packaging of integrated circuits. So what type of films can be used for thermal spreaders or thermal isolation or to help facilitate the operation of these increasingly complex integrated circuits. And then we also do a lot of electrical device testing. So there's opportunities to work with probe stations, both cryogenic probe stations and high temperature probe stations, and just look at how, fundamentally, what are the important electrical characteristics of a transistor and how do those characteristics, change with temperature or the environment. And so we have a variety of PhD group students in our group who you'd be able to kind of shadow under and sort of hit the ground running because at first it can be disorienting being in a lab. So we have a lot of kind of senior expertise who can kind of take you under their wing, both at the PhD and at the master's level. And I put my contact up on the top there. So again, we have a webpage that kind of talks about what we do with links to some of our publications. And there's my email as well, so you're welcome to reach out and sort of get a better understanding of the projects that we do in our group. So with that, I won't take too much of your time. I just wanted to give you a short, quick introduction, and I'll pass it back to you, Rick, and then we can share it with the next representative.
Okay, thank you, Dr. Brenner. That's very exciting work you're doing in your research there. Thank you for sharing that with us. Okay, next up is Dr. Mona Goswami. Dr. Goswami, are you online? Not sure if she was able to join or not. Okay, I don't think so. Okay, so Dr. Wong from Material Science and Engineering, we'll go ahead and move to him. He's actually sent me his slides, so I will advance. And Dr. Wong, I'll turn it over to you.
Thanks, Rick.
Oops.
Yeah, so I'm an assistant professor in the MSc department. My research focus on wide bandgap semiconductor devices and material. So this slide basically summarizes my research work. So you can see from the bottom images, we do some material growth. This is gallium nitride material. So, for gallium nitride or wide bandgap material is that it can be, one feature is that you can see the light coming out from the semiconductor material, whereas for other semiconductor materials such as gallium arsenide, indium phosphide, they emit in the infrared, so you will not be able to see the light at all. Whereas for wide bandgap semiconductor, you can actually see the emission, whether it's blue, green, or red color. So my group focused on the material development of wide bandgap semiconductor, as well as the device fabrication. So after we grow this material using different techniques, then we can fabricate these material into different useful devices. For example, here I'm showing we have micro LEDs, basically very tiny LEDs, or laser diodes. So these optical devices, they have various application in semiconductor manufacturing, packaging, application, quantum communication in data center, display for AR, VR application, as well as biomedical and novel chemical synthesis applications. So if you go to the next slide, as Rick mentioned earlier, that why bother to study wide bandgap semiconductor devices or material? So echoing back with what Rick said earlier, data center for AI is definitely very important for the future development. Whether it is a bubble or not, we do need a better, if we're more efficient data center and with better energy efficiency. One way to do that is to employ wide bandgap material in devices such that we can be more green about data center. So here I'm showing you a pie chart on the left, where you can see that most of 50% of the the energy used by data center is actually from the cooling system. So if you walked into a data center right now, you wouldn't feel any heat from the rack. You just it's because everything is cooled by either AC or water cool to maintain the room temperature that you would expect it. And during this process, most of the energy is consumed just because of that. I'm not talking about running the process or computing the data. It's just by cooling. So one big benefit of using wide bandgap material is that, as you can see from the table, that because they have wider bandgap compared to conventional silicon material, they can be more tolerable in under high temperature and extreme environment, such that they can maintain their efficient performance at high temperature. And these wide bandgap material, they have various application in defense, grid, as well as aerospace, and different AI related applications such as AR, display, and data center. So if you go to the next slide, yeah. So in terms of what I'm working on, or my group is working on, we have different projects. Part of it is photonic devices that includes visible micro LED for display and datacom application, and also not only we want to see the light emitting from the devices, we also want to collect light and detect it by our devices. So that's why we have some full detector projects. And then on the other hand, we also have some electronic devices that suited for more conventional semiconductor manufacturing technologies, such as using gallium oxide as a power devices, as well as doing some work on gallium nitride hemp devices, and to study the device degradation under harsh environment. So with that, that's my research summary. Thank you.
Okay, thank you, Dr. Wong. Very interesting. Okay, so again, I want to put up the QR code here. This is will take you to the Scholar Program web page. This is the link. I'm going to go there quickly. Do you see this? Hopefully it's okay. Do you see the web page here?
Yes.
Okay,
I see
good.
the code. Yeah.
Okay, good.
Yep.
Oh, no, I was okay. Let me see if I'm sharing correctly.
It did not. You mean did the hyperlink appear?
Okay. 1 second. There. Okay. You see it now? Okay. Do you see the web page of the Scholar program?
Yes.
Okay, good. Okay, so I'm not going to go through this in detail, but I just want to show you the web page and where you're going to find a lot more information about this. You'll want to go visit that. It goes into the requirements again, but what I really want to show you is what I've mentioned. This are the 20, we have 21 now participating faculty advisors. And so if you, on this page, you can see what their research is about kind of at a high level. You'll see those that presented here to us today. And if you go click on one of those, I'll go to Dr. Brenner's here, and you see his bio and then some more details about the research projects. So definitely you'll want to go visit this page. And again, it has information on it regarding full details and about applying for this fellowship and everything that you need to do. So just wanted to show you that real quickly. Go back to. Okay. So I think that was it. The last is Q&A. So at this time, we'll open it up. If you have any questions, you can speak up or you can type them into the chat. Maybe if they go into the chat there, Christy, you can read them to us.
I'm monitoring the chat. I don't see anything right now.
Okay. Anyone have any questions?
There are some questions now coming in, Rick.
Okay.
One question is, what are you looking for in an applicant?
So, well, it depends on which program that you're applying for. So if you're applying for the mechanical engineering program or electrical engineering or the material science and engineering, you've got to be accepted into that department's program. So it would be, meeting the requirements of what they typically have. Provided that you meet that, we're really looking for people who have an interest in the semiconductor industry, semiconductor technology, and who are willing to do a thesis-based research project. Our expectation is that most of you, if you go through this program, you're going to get the master's, get more information specifically on semiconductor technology as part of your master's. And then you would be able to go work in the industry as someone who is more fully prepared. And that basically is why this funding came about, to help meet this demand in the industry for highly qualified people that have had extra training and preparation in semiconductors. So what we're really looking for is if you have, good, solid grades as an undergrad, and you have an interest in working in this technology, and that comes out as in your application through what you submit. That's really what we're looking for. Good question, though.
Another question has come in. How can an MSE applicant stand out?
Okay, well, again, in this, in this area, you're going to be MSE applicants. You're going to be working on different aspects of materials, particularly as related to semiconductor technology, as our two professors spoke about today. The way you stand out, I think, is again expressing, maybe having some knowledge of what area that you want to work in. You would get that through reading the professors' bios and, maybe why you're interested in that particular research area or project. And, again, a career that's aligned with, someone who wants to go into the semiconductor industry. As I showed from the earlier chart, we anticipate there's going to be a tremendous demand because of the growth, the reshoring of this manufacturing, the semiconductor industry back into the U.S. And so if we can see that expressed in your application and you have, a solid undergraduate, grades and experiences, that's what we're looking for.
Another question is, are you recruiting international students or not?
Well, this particular program, you must be a U.S. citizen or a U.S. permanent resident. And that was the funding that was made available to support this. That was one of the stipulations, was the recipients had to be U.S. citizens or U.S. permanent residents.
And another question has come in. How will this program prepare for working in semiconductor industry, like the skills and experience?
Well, I think what it's going to do is, you come in, you may have an undergraduate degree in, electrical engineering or mechanical engineering that's more broad. This is going to get it focused, particularly on the semiconductor industry. Material science, I will speak to that one because that's more the path I took. I was a materials and process engineer. And my background was in chemical engineering, but I got a master's degree while I was working, actually, but it was a master's degree, and I got to broaden my understanding in semiconductors, and that made me a much more productive engineer in the semiconductor industry. So I think what this is going to give you, and again, that go back to this page, this certificate in semiconductor technology. These classes are going to give you a good working understanding of, semiconductor materials, how you affect the properties, how you do the processing of semiconductor materials. So you're just going to come out with a leg up on people who haven't had this kind of training as part of their education. I think you're going to stand out. Your resume is going to stand out because you're going to have directly applicable experience as well as your research that you do for your master's thesis. So if you go through this program, I fully expect your resume is going to move up to the top when they're considering people to hire. And in fact, some of you may have, you may be hired directly out of the program through the contacts that you make from the industry mentors and the visits that we make to industry locations. We will be trying to put you in contact with the companies in this area. And as you present your research from your master's thesis, most likely you'll be going to a conference somewhere to present that, which again is going to attract people from the semiconductor industry that are hiring, not only from North Texas, but from across the country.
And Rick, I guess the only thing I'd add on that is that, there are companies in the local area with whom we interact, frequently. And so there'll be a lot of opportunity in just in those kind of interactions also, which may not occur in other parts of the country.
Yes, that's true. Thank you, Ted.
Another question we have received is, does the scholarship cover out-of-state tuition? And also, will it continue in the next 3 years, say a cohort starting in the fall of 2028?
Well, the first part is it does fully covers tuition, whether you're an in-state student or an out-of-state student. So that's covered as part of the fellowship. Now, beyond the next 2 years, right now, the funding is only there to start a cohort in 2026 and 2027. We're hopeful that, given the output of this, that we would receive funding to continue it. But at this time, the funding is only certainty for the next two falls, fall of 26 and fall of 27.
Another question that has come in is, I saw on the website that a job is not allowed to be taken over the summer. Is there any leniency on that?
No, because we expect you to be doing your research that you're writing your master's thesis on, and we would be paying you during the summer. So, you're going to be paid for basically 5 semesters, a very nice stipend of at least $2,150 a month. So, in this program, during that summer between your first and second year, we would expect you to be doing your MS thesis research.
Another question has been received. Are there in-person interviews for the graduate school application process? I mean, it looks like they're meaning with the program, the degrees, if I'm reading that correctly.
I don't believe there typically is. I suppose you could be contacted, but I think the application process is normally you submit the materials. Now, if the department has a question, they might reach out to you, but I don't believe that's typically part of the admission process. Now, you're certainly welcome if you're looking at, different professors to reach out to them and ask them additional information. You'll find their contact information on the UT Dallas website. Dr. Brenner gave his here today, but it would be easy to find. And if you have questions about their research, that would, we would certainly encourage you to reach out and ask those questions. And, from the information you gain from those interactions, you're probably going to be able to write a stronger, letter of what your interests are. And, that's one of the things that might make you stand out as a student who has, definitely shown a strong interest in the research that's being done here on semiconductor technology.
We have one more. Thank you. Are cohorts strictly starting in fall semesters only?
That's the way it is set up. Yes, we would start. It would be for students starting in fall of 26 and for fall of 27.
And
Now, if you're a UT Dallas student and you're on fast track, where you may already have a couple of your graduate courses completed, and that's fine. But you would need to be fully completed with your undergraduate degree and be a full-time master's student starting in fall of 26.
And I'm checking the chat. I don't see any more questions in the chat or in the Q&A. I think that we have covered them all now.
Okay, very good. Well, thank you everyone for participating. Again, I'll leave it here on this QR code and would encourage you to visit our website and to take advantage of this very unique opportunity, a fully funded master's degree. A fellowship with a stipend does not come along that often. So again, if this is something you're interested in, we would definitely encourage you to take advantage of it and apply to one of the 3 departments and to submit your fellowship application. So thank you for your time today, and good luck with the rest of your undergraduate studies, and we hope to see you here in fall of 26. Thank you.
I'm just checking. They're saying thank you, Rick.
Okay, great.
Okay.